People. The world is people, and people travel, and the world is smaller. They travel by rail across countries, across continents, on a road of steel. Trains are for people, designed for people. The New South Wales Railways wanted a very special kind of train, an electric train to service the rapidly expanding residential development in the Gosford-Brisbane Waters area to the north of Sydney. A train which would be fast, with the capacity of carrying large numbers in quiet, air-conditioned comfort. An ambitious project. The designers and builders chosen for the task, Commonwealth Engineering. Design and innovation, once conceived, can be quickly translated to the drawing board. But every electric and mechanical function, no matter how small, will be the end result of countless man-hours of exhaustive design, modification and testing. The overall design is that of a stainless steel double-deck car, 77 feet long, 14.5 feet high, and nearly 10 feet wide. From early sketches, final designs and working drawings begin to emerge. A vehicle of that size needs a very special chassis. In the carbon steel plant, sections of that chassis are cut into shapes and lengths preparatory to arc welding. Many apparently unrelated stages are prepared simultaneously in various parts of the plant. Here, a draw bench presses flat stainless steel into side panel flutes. With the exception of the carbon steel chassis, almost all other metal in the car is stainless steel. It is light, very strong, and requires no maintenance. The stainless steel shop is thus charged with the task of drawing, stretching, pressing, cutting and drilling this versatile material into a myriad of shapes and lengths. This machine both bends and stretches a length of stainless steel to form a roof car line. As spot welding is used to join sections of stainless steel rather than nuts and bolts, the strength of those spot welds must be constantly tested. Sample pieces are welded together and subjected to a prescribed strain, which is far in excess of anything likely to be encountered in normal service. Spot welding in action. A roof section in corrugated stainless steel. An inverted lower floor frame about to be lowered into its assembly jig. The same floor frame with equipment supports being welded. Air brake equipment. A stainless steel side wall section. More spot welding. That lower floor frame is now right way up, and a fluted sidewall lowered into position. And spot welded to it. This car, or rather shell, is now at a crucial stage, with chassis, underframe, sidewalls, roof and end sections, and its distinctive one-piece moulded fiberglass front completed. The car will now be subjected to more stringent testing. The first of these is the water test. Deluged on all sides, even the smallest leak is instantly apparent and rectified. The strain gauge test, also a structural one, is even more exacting. A test which combines maximum vertical and end compression loads. The car is squeezed by a powerful hydraulic ram in a compression ring. Sensitive recording equipment, attached at strategic points on the car, will reveal any structural weakness in the chassis or body. Again, the measured stresses and strains which the car will withstand far exceed those of normal operation. With the confidence in a sound, strong chassis and body, interior fittings can now be installed. Not surprisingly, the floor is first. Polyurethane foam is sprayed into the walls and ceilings, providing both soundproofing and heat insulation. Stairway panels can now be fitted. An uncomplicated item, such as the moulded fiberglass stairs between the lower and upper decks, have been painstakingly designed to stand up to the heaviest treatment. Their installation is no less careful. Flush-fitting roof panels, wall lining panels, moulded fiberglass window surrounds, and luggage rack all contribute to an attractive, functional and uncluttered interior. Throughout the car, large picture windows are fitted in double-pane glass and tinted for glare. fluorescent light fittings fit flush with the ceiling. Floor covering by Treadmaster. Non-slip, long wearing. With passengers always in mind, the car's seats are the subject of thoughtful design. Here, designers examine a prototype. Tested satisfactorily, the design goes into production. The material is cut, sewn, and trimmed over foam rubber. And finally, installed in the cars. Side entrance doors. Pistons, sleeves, cylinders. Pneumatically operated, safe and secure. The car's end doors allow easy access between cars. Much of the car's control gear, not required by the driver during normal running, is located in the rear of the car. Amongst these are the air conditioning controls, as well as those for the auxiliary motors. The driver's compartment houses all instruments and controls related to the actual running and stopping of the car. The instruments, large and easily read, include amp meter, brake pressure and speedometer. Sealed windows, insulated interiors and concealed ducting makes air conditioning efficient and easy to maintain. The unit itself is neatly installed in the roof. Similarly, resistors, which control the traction motors, are also installed in the roof. With all electric controls now installed, the exhaustive task of checking and rechecking all individual circuits is jointly carried out by Commonwealth Engineering and New South Wales Railways technicians. Outside, electrical testing continues. The main motor connections. Until now, near-completed cars have been transported around to various shops by all manner of cranes and jigs, pushed and pulled by heavy tractors on temporary shop bogies. It is now time to lift the car and remove these and install what can only be described as a complex of air and rubber suspension, coil springs, air brakes, shock absorbers, and two 1500-volt traction motors. These gleaming new black bogies are the reality which represent the speed, safety, and smoothness for which the car was designed. Once in place, the car is then lowered and the new bogies secured. Today is a proud day because today the first 4 brilliant stainless steel double-deck cars are being handed over to the New South Wales Railways. The culmination of many months of hard work, frustration, and the determination to produce what is now all too evident, the finest example of passenger rail transport in Australia. Railways Commissioner Mr. McCusker.
I'm extremely proud, and that goes without saying, today to have the privilege on behalf of the New South Wales Railways of accepting these 4 carriages, the first of 16 to come. My pride stems mainly from the fact that they're wholly Australian. They've been conceived and designed and built by Australians in Australia.
But although these cars have been officially handed over, actual test running has still to be carried out. Only so much of a car's performance can be ascertained under simulated conditions at the factory. Motors, brakes, air conditioning, automatic doors, and indeed all electrical circuitry must be fully tested at various speeds and adjusted, modified, and readjusted until every mechanical and electrical function perform perfectly under all conditions. And so it's backwards and forwards, stopping and starting, backwards, forwards, stopping, starting.
Central Station in Sydney, and the cameras are out in force. No water for this new baby, she's all electric. She's the latest and most modern train in New South Wales and will go into service on the Sydney-Gosford run. A double-decker, fully air-conditioned, and everyone's eager to get a closer look at the new arrival, all in shiny stainless steel. A cold, bleak day, but everyone's in high spirits for her inaugural trip. Smile for the press, boys. Transport Minister Morris and Railways Commissioner McCusker are justly proud of their new baby. So it's all aboard. Only press and VIPs this time, but after today, it's goodbye Sydney, hello Gosford in just over an hour. Bon voyage, pretty baby.
Commonwealth Engineering's double-deck interurban cars have now gone into full-time service. They represent foresight and confidence by their purchasers, and a great achievement in electrical engineering by the designers and engineers who built them. With the people who travel in them goes the knowledge that these cars are the most modern and technically proficient examples of rail transport today.